Hey, welcome back. About 4 years ago, I made a video about building this pedal-driven catamaran, which has been watched by over 1 million people at this point, and I figured it's about time I give you an update on this project. Like most things I build, this boat is very much a prototype, and since building it, I've had a lot of fun with it, but I've also encountered quite a few technical issues and also had a lot of new ideas for it, so in this video I'm gonna revisit this project and improve a bunch of things about the boat to make it even better. Before we jump in, I just wanted to clear up a few things about the idea behind this project. Back when I uploaded the first video about this, a lot of people didn't understand what I was trying to do with this whole concept, which is mostly on me, because I didn't record voiceovers back then to explain things, so I'll try to quickly explain the many considerations that led to this design. So I live in Hamburg, which is a city that has a lot of very nice waterways to explore, which is the main reason I always wanted my own boat. And the most popular area to use a small boat here is a lake right in the center of the city, which is called Alster. One thing that's important to know is that for this entire lake and all the little canals that connect to it, there's a very strict rule which forbids you from using any kind of motor. This includes any and all gas-powered outboard motors and also any electric motors. Unless you have special permission, you're only allowed to use things like canoes, stand-up boards, kayaks, and so on. So this was the main reason I chose to build a pedal-powered boat. A lot of people also suggested that I should put a sail on this boat, which is allowed, but another feature of the canals here is that they have a ton of low bridges. So if you want to move around anywhere outside of the main lake, having a sail becomes an obstacle more than anything else. But apart from that, I'm also simply not interested in sailing. The most tricky design aspect this boat had to pull off was that I wanted it to be transportable using a bike. Because I don't own a car and I'm generally opposed to the idea that cars have to be the solution for absolutely everything, so in order to achieve the goal of moving this with a bike trailer, the boat also had to be fairly light and it had to be possible to easily assemble and disassemble the whole thing. The size of it was also a design goal I set myself, because I didn't want to build something to just purely travel on the water like a canoe, but rather a large platform that you can actually spend some quality time on. So making a large catamaran allows to have space for up to 4 people to hang out on the boat without any risk of tipping over. You can move around on it and it's actually comfortable to sit on or lie down, and you can even go swimming or take a nap on there. Plus it has tons of space for cargo thanks to the open hulls. Speaking of open hulls, one concern that people brought up a lot was that the boat would sink when waves fill up the hulls with water, but I think after explaining what purpose this was made for, it should be clear that you wouldn't use this anywhere you wouldn't use a canoe. It's obviously not made for the open sea or any kind of harsh weather conditions, and I'm sure you could find a million other approaches to meet the design goals I mentioned, but this was my solution, and hopefully that clears up a few things about why this thing looks like it does. With all that being said, since this is a prototype like I mentioned, there were of course a few things that could use improvement, so let's take a look at some of those. One of the main issues I had with the boat was that this assembly in the back that drives the propeller and contains the rudder was simply too long. The lakes and canals here are actually very shallow in some places, especially when you get close to the shore, so every now and then the rear drivetrain assembly here would scrape on the bottom, which would not only potentially damage it but could also get you stuck. So the main thing I want to do is rebuild this entire module, shorten it by about 20 centimeters and slim it down overall. One reason the rear drivetrain had to be so long was also due to the type of propeller I used. Many people in the comments assumed that this kind of propeller is somehow incorrect because it's made for model airplanes, but I did do a lot of research for this project, and even if you don't believe me, this style of propeller with long thin blades gives you the best efficiency for human-powered boats. So you get the most speed for the least amount of effort, which is why you see this style of propeller on many similar boats. Unfortunately, there is a big downside to this style of propeller, which is that they tend to catch debris in the water. So the drivetrain would often get jammed up by random leaves, twigs, trash, and anything else that floats in the water, which is why I decided that this time I'll try sacrificing some efficiency to go with the more traditional boat propeller, because the shape of these makes it much less likely for stuff to get tangled up in it. Since this propeller is also much smaller in diameter, this is going to allow me to make the entire part of the drivetrain that sits underwater much shorter, which should severely reduce the risk of it scraping on the bottom and also reduce the overall drag by having less surface area submerged. Instead of using aluminum box section, I also figured I can simplify this whole tube that extends into the water by using this oval shaped profile, which already has a more aquadynamic shape so it doesn't need that sheet metal fin I attached to the old one. Also, instead of having the block that contains the propeller axle move up and down for tensioning the belt, there will just be a spring-loaded belt tensioner up top, so this part can be fixed directly to the bottom of this tube, which further simplifies things. So the first task was to make a new axle block for the propeller. To attach the block to the tubing, it gets a thread, and then I made this little part that is shaped so it can go inside the tube, and then it's secured with 2 screws. Over the course of using the boat, I experimented with several types of bushings and bearings to use for the propeller, and at one point I even tried ball bearings underwater, which actually worked pretty well for a while. But of course they did inevitably start rusting, so this time I'm going back to my first solution, which is a special type of plastic bushing made by a company called Igus, and the type I'm using is specifically made for underwater use. Now we can press in the bushings I mentioned, and for the axle that goes in here I can reuse the existing one, but it needs a few small modifications to work with the new propeller. I'm also reusing the old belt pulley, but this time it will get attached using a slot and key, and while it is made from aluminum, the flanges are sheet metal, so it got a bit rusty over time, which is why I decided to sandblast and paint it. Now these parts can be installed, so the axle goes inside the bushings here and gets a key, and by the way, the drive key and all the screws here are stainless steel, so nothing that sits underwater should develop any rust this time. The propeller gets driven by this little pin and then secured from the front using a lock nut. And now the new propeller assembly is finished, so I'm going to move on to a different part of the drivetrain. So this is the center beam that you sit on, and that also contains the other parts of the drivetrain. We have a long drive shaft here that runs from the back to this little gearbox, and the rear part of the drivetrain can actually rotate sideways like this, which allows you to basically retract it for when the boat goes in and out of the water, and also to be able to do maintenance on it while you're on the boat in case something goes wrong or gets clogged up. While this does work well already, I was never quite happy with it, so here I'm taking the mechanism apart to show you why. So this angle bracket here rotates on this plate and around the drive shaft, but it's not actually touching the drive shaft. The hole in the bracket is a bit larger on purpose to allow clearance for the shaft to pass through there without contacting it, because the bearing is actually contained in the plate. The problem with this setup is that when the bracket rotates, it essentially rides on the locking screws that sit inside the slots here, since it's not actually supported in the center. And as you can see here, the threads have already dug into the aluminum here quite a bit, creating these deep scratches. So in order to improve this, I'm going to put a new bearing here, but this time it actually sits on the moving bracket, while the plate will get a small plastic bushing that the angle bracket will rotate on. So here I'm creating that bushing using some POM, which I think is more commonly known as Catamaran in the US. This now just gets pressed into the plate that used to contain the ball bearing, and the hole in the bracket gets enlarged a bit. And now the two can interface like this, so the angle bracket now has a clean and smooth center of rotation. It also gets some threads to mount the new bearing, and then I also decided to put it on the rotary table once again to clean up those slots that were all messed up from the screws. Now I can reinstall all this stuff, and the drive shaft gets installed later, but this is already a huge improvement over the previous solution, because the screws don't actually contact the slots at all now, and the rotation is a lot smoother. Next I have to figure out a way to attach the new propeller tube to this bracket, so I decided to just weld a plate onto the end of it so the two can be screwed together. I used a plate that's a bit bigger than I need, so I can actually mill it down to size after welding, but the other reason it goes on the mill again is that welding plates like this usually results in a fair bit of distortion, so to get a clean interface and make it flat again, I'm facing the bottom of the plate here. Then everything gets matching mounting holes, and now these two can be screwed together. The rear part of the drivetrain is almost done now, so next up is dealing with the front part. And this was also something I had a lot of issues with, which mostly stem from this little angle gearbox. You can see here that when I turn the crank, this actually wants to move around quite a bit. And the reason for that is that the axle that drives this simply has too much runout. Back when I built the boat, I had a hard time figuring out how to make an axle where I can mount a bike sprocket on one side and have the other side interface with this gearbox. So what I ended up doing was to use a standard BSA square taper bottom bracket for bikes, so that I could attach this cannibalized crankset on one side, and on the other side I welded on this adapter I made, which fits into the gearbox. The big issue with this is that it's almost impossible to get decent runout from a part that's been welded on, unless you machine it after the welding, which wasn't possible in this case. So that means the adapter sits on there a little crooked, which causes the wobbling in the gearbox, and that causes the whole drivetrain to be less smooth and efficient than it could be. So this time I figured out a much better solution for this. Instead of using a cartridge type bottom bracket where the axle is fixed inside this whole unit, I can just use a more modern bottom bracket designed for hollow cranks. In this case, the bottom bracket is really just a set of bearings with these threaded cups, which means I can make an entirely custom axle that actually runs true. The best thing is, it's not even expensive. I bought this Shimano Hollowtech bottom bracket, which only costs around 15 bucks, and this is now going into the BSA shell. Instead of using a modified crank like I did previously, this time I also decided it makes much more sense to actually use sprockets instead of a small chainring, because it allows me to go even lower with the tooth count, creating a higher gear ratio. So I'm gonna steal the Hyperglide freewheel body from an old rear hub for the axle, which will allow me to mount any size standard sprocket I want on there. These things have a freewheel built into them, which I don't need for this purpose. I really just want the outside shell that accepts the sprockets, because this spline shape is pretty tricky to make yourself. So I put this thing on my hydraulic press to remove the internals, and I later found out you can actually disassemble these things without exploding them, but I pulled this up from the trash anyway, so no harm done. Next I'm cutting a steel tube to length that will make up the main part of the axle, and we'll get various pieces attached to it on both ends. This part I'm making here is a little stud that will get pressed into one end of the tube, and then I'll machine it into a hex shape to interface with the gearbox. The center of the tube now has the correct dimension for the bottom bracket, so let's give that a try. Looks like it fits in there nicely, so next up is making the hex drive. I made this little stud a little bit longer than it needs to be on purpose, because this way the end fits into one of my hex-shaped collet blocks, which unfortunately isn't big enough to fit the larger section of this part, so this was my compromise. So the hex shape is done now, and the excess on the end actually doesn't get cut off. I'm going to turn this into a thread which will hold the axle in place later. With this, one side of the part is finished now, so I need to figure out how to attach the free hub body on the other side. For that, I'm first cutting the tube to its final length, and then I'm creating another part that will be pressed and welded into this side like last time. So this now gets turned into a shape that I can then press and weld the free hub body onto. And the whole idea with this approach is to make sure it goes on there as straight and concentric as possible, which is why the part has that shoulder for the hub part to slide against. Now these two parts are joined together, and afterwards I also checked the run out in the lathe, and the whole thing runs nice and true, so going the extra mile here paid off. I'm pretty sure with this press fit and those teeth inside the hardened steel free hub digging into the axle, this might just be strong enough as it is, but I still decided to weld the outside once more just to make sure this lasts a long time. Then it got cleaned up in the lathe again, and I also cold blued and oiled it to add some rust protection. So here's the finished part now, and this is probably one of the strangest parts I ever made, but I'm really happy with it because there's zero play inside the bottom bracket here, and everything fits together nicely and runs much more true than before. Now there's just one last thing I want to add. Before I just used some nuts as spacers between the gearbox and the frame, so this time I 3D printed a part for this that has a chamfer to clear the weld, and it completely seals up the gap on all sides, so this should prevent dirt from coming in. With that done, I can now reinstall the drive shaft and then finish the installation for the front part by putting the crank assembly back on. I used the smallest sprocket I could find this time to increase the gear ratio, because since I'm using a much smaller propeller, I'm assuming it needs to turn at a much higher RPM to get decent speed. Now this part of the drivetrain is fully operational again, and I can already tell it runs a lot better than it used to, but before we connect the rear part with the propeller, There's just one last thing to do, which is to adapt the steering mechanism to the new parts in the back. I'm mostly gonna reuse parts from the existing steering system because it worked quite well, but like before, everything is going to be slimmed down quite a bit. I found this little block here in my scrap bin, and it actually happens to be perfect to become the new steering joint, so the existing cable steering pulley here will be attached on top of that. I'm also reusing the angle brackets the former rudder was attached with, but they're going to be much closer together now, so the idea is to put them together like this and attach them to the tube that goes in the water. So that tube gets some mounting holes, and I 3D printed another little part here. This is just to go around the curvature of the tubing on one side to provide a flat surface for the brackets to attach to. Here I'm cutting some aluminum sheet metal that's going to be the new rudder, because in retrospect the old one was pretty clunky and a bit overbuilt, so I think just a flat piece of metal will do the job here. The small part I modified before now gets a slot down the center where the new rudder neatly fits in. I also made this part, which will hold the cable stops for the steering, and the reason it has so many holes is that I wasn't sure where exactly I need to put the cables so they don't interfere with the drive belt, so this gives me a few different options. Speaking of the drive belt, this can now also be installed, and it just needs something to tension the belt now, because it would slip otherwise. So I'm going to slightly modify this thing, which is a chain tensioner, normally used for single speed bikes. Fortunately, I don't have to do much to it. I'm just adding some POM spacers I made on the lathe, and then the belt pulley fits on there instead of the sprocket. I think I want to attach this to the top steering bracket here, so I'm gonna make a little adapter for that. I also cut a slot into the bracket you saw, and this allows to move the tensioner back and forth a bit to line it up with the belt. These little holes here are for this pin to engage in, which sets the preload for the spring inside there, so depending on how I rotate this, I can try out different settings. And with all this installed, we can now finally give the completed new drivetrain a try. This all seems like it runs nice and smooth, and I'm getting some serious RPMs at the end there, because the overall gear ratio of the system is now somewhere around 20:1, in case you're interested, and as you'll see later, they turn out to be a good guess for this propeller. Now that I know everything works, I can finish the steering assembly here, and you can see what I was talking about with the cables. I ended up using the outermost positions for the cable stops, so it's good I made the part so long, and this way there's enough clearance now. I also took apart the handle and cleaned up all the parts because everything was a bit gunked up in there. And here's the completed new-ish steering system. One last thing I did was to do some small improvements to the hulls and the frame of the boat. The hulls had been sitting outside for a few years without any weather protection, and they were full of dirt, so I gave them a good cleaning first. So to put the frame together, I used to just use these bolts and nuts, and assembling the boat this way and fumbling around with the nuts and tools has always been one of the most annoying things about using it. So I figured I can make the assembly way easier by making it virtually tool-less. I'm doing this by installing rib nuts into all the places where the screws go, which again is something that I could have done back then, but I just didn't realize it's a possibility. The bottom holes of these beams were also enlarged so they fit around the flanges of the rib nuts. And then I also bought a bunch of these plastic screw handles and glued in some all thread cut to the right length. And now the entire boat can actually be assembled and disassembled without using a single tool, which makes it much more convenient. So assembling the entire boat takes about 30 minutes, most of which is spent rigging up the trampoline surfaces, which I'm skipping in this case. And it's ideally done by 2 people, but as you can see, it is possible to do it alone. At this point, the last time I actually used the boat had been over 2 years ago, so I put the entire thing together in the shop once, where it barely even fits in, to see if there's any obvious issues, but it looks pretty promising overall. Something I added after the first video is these things that are called float bags. They're essentially just air-filled bags that would keep the boat from sinking completely in the worst case scenario of the hulls taking on water. But as I said earlier, this is a fair weather boat made for small lakes and canals, but it doesn't hurt to have these just in case, and I also always bring a life vest when I use this boat. So the boat is now ready to use again, and just to answer one last question people always ask, I decided to weigh the parts because I was also curious how heavy it actually is. The hulls come in at around 17 kilos each, and the center beam with the drivetrain weighs about 22 kilos. And together with the other parts, this puts the entire boat at around 66 kilos, which is about what I expected, because it's relatively manageable to carry it with 2 people. After all this work, I of course had to get this into the water at least one last time this year before the weather turns too bad for testing. And with all the headaches this project has given me over time, I was pleasantly surprised that this time there were no major issues at all. I had a small problem at first with the drive belt slipping again, but that was quickly fixed by increasing the belt tension. And besides that, the new drivetrain is doing a great job. I didn't have any issues with the propeller getting jammed by debris anymore, and the steering seems to work about the same as before. The boat also seems about as fast as it was before, so I think I didn't lose too much speed by using the smaller propeller, but I'm sure it would have been slower if I hadn't increased the gear ratio as well. I know lots of people want to know how fast the boat actually is, but it's kind of hard to give a clear answer for that. It depends on how many people are on the boat, of course, but just to give you a rough idea, with moderate pedaling, I'd say it's about as fast as your average canoe, but at the same time it feels like a lot less effort. If you're alone on the boat and really pushing, you could maybe even keep up with moderate to fast kayaks, and especially if you ride bikes a lot, you can basically go all day on this thing without getting tired, which is something I love about it. It's just so much more comfortable and efficient than crouching in a canoe and having to hold a paddle the entire time, especially if you have long legs, but I admit I might be a bit biased here because I was never a big fan of canoeing. Unfortunately, it's now fall here, so the boat is once again in hibernation mode, but I'm hoping to put this to good use in the coming year, and since I'm still not done improving things about it, there might be another video on this at some point, but I'm also considering to make plans for this if there is enough interest. For now, I hope you enjoyed this project. If you got any questions, drop them in the comments, and thanks for watching.